In this video, we're going to talk a little bit about what are called inverse functions. So we're going to start out with a definition. So the composition inverse of a function, if it exists, is itself a function, f inverse, which we denote by f upper minus 1, which is important to understand is not the reciprocal 1 over f, but rather a function that when you compose f and f inverse in either order, whenever you plug something into the function, you get that object back out. Equivalently, if you don't like this formulation from compositions, you can think of it as saying that y is equal to f of x if and only if f inverse of y is equal to x. So you can sort of think about the composition inverse as undoing whatever operation f does. This latter characterization tells us something about the domain and the range of these two functions. So the inverse function takes in as input outputs of the function f. So that says the domain of f inverse is the range of f, while its set of outputs, all possible outputs, are all the possible inputs to the function f. So one way that we can identify whether or not a function has an inverse is by the horizontal line test. So the horizontal line test says that a function f has an inverse if and only if anytime you draw a horizontal line, that horizontal line intersects the graph in either 0 or 1 point. A good example of an invertible function is a line. So any line that is not horizontal is going to be an invertible function. We can find the inverse by solving y equals mx plus b for x in terms of y. So we get the expression x is equal to 1 over m times y minus 1 over m times b, which tells us that the function, which is the inverse of mx plus b, is also a line, and its slope is 1 over m. And you can check that if you compose these in either order, you'll always get x. So since we usually express the inverse function as f inverse as a function of x, we will simply reverse the x's and the y's. So if our function is f of x equals mx plus b, then we usually express f inverse as 1 over m times x minus 1 over m times b. So we can see if we compose in either order, then we'll always get just x back out. A good example of a function that is not invertible is the function x squared. So we can see here, if you pick your favorite positive number b, and you draw a horizontal line, y equals b, it will intersect the parabola in two places. The first place is the positive square root of b, the other is the negative square root of b. So it's important also to note that the square root function is not actually the inverse for the square. The reason for this is while squaring the square root gives us x itself, the other composition actually gives us the absolute value. So we can see here that if you take the square root of a negative number squared, you don't get that negative number back. In fact, you get its absolute value. So a second way that we can express the absolute value function is as the square root of x squared. So one last fact about inverse functions is how to graph them. So if you know how to graph the function f, you can graph its inverse simply by reflecting across the line y equals x. So for example, if we take the function x cubed, since every number has a unique cube root, the cube root is actually the inverse. So if we know how to graph x cubed, we can simply take that and reflect it across the line y equals x to get the graph of the cube root. So we can see here in green, we have the line y equals x. In blue here, we have y equals x cubed. So to obtain the graph of the cube root of x, we simply take this and flip it over the green line. And that's all.